Hello everyone, this is part 2. In this video I am going to discuss a more efficient solution to solve contains duplicate problem. If you have not watched part 1 of this video, I highly suggest you to watch it so that you better understand the problem statement and the brute force approach. So we are given an array 174, 11, 10, 7, 9 and two integer values k and t. We have to find a pair within this array that satisfy these two constraints. The absolute difference between the values of the pairs must be at most t, and the absolute difference between their indices must be at most k. So in our new approach, I am going to use a property. I am going to use the inequality property of absolute value. We all know that mod of y minus x less than or equal to t can be written as y minus x greater than or equal to minus t and less than or equal to t. So the value of y becomes x minus t greater than or equal to x minus t and less than or equal to x plus t. So if we know the first number of the pair, we also know the range of the second number. And also note that we don't really need to find the exact pair. We just need to find whether there exists a pair in this array that satisfy this constraint according to the question. So if the first number is 1, okay, or if the first number of the pair is 1, then we know that we have to find the second number from the next k numbers, because we have to satisfy the second constraint also. Okay, so we have to pick the second number of the pair from the next k numbers. And if the first number of our pair is 7, then we have to pick the next number of the pair from the next k numbers, 4, 11, 10. Similarly, if the first number of the pair is 4, then we have to pick the next other number of the pair from the next k numbers from 4, which is 11, 10 and 7. And also similarly, if the first number of the pair is 11, then the second number of pair we have to pick from the next k numbers from 11, which are 10, 7 and 9. Okay, so we also know the range of the second number. Okay, so if the first number is 1, the range becomes 1 minus 2 to 1 plus 2 minus 1 to 3. Okay, so we just need to see whether there exists a number in this array that lies in the range minus 1 to 3. Okay, so there is not any number. And also note that we don't really need to iterate through this whole array 7, 4 and 11. Okay, we can maintain a structure, a data structure, tree set. Okay, we can maintain a data structure, tree set, that will going to sort all these values. Okay, and it stores no duplicate values, so it will store 4, 7 and 11. Okay, for this case also it will store the numbers in sorted order 4, 10 and 11, and for this again it will store 7, 10 and 11, and for this it will store 7, 9 and 10. And also note that we don't need to maintain a separate tree set data structure for all these arrays. We just need to maintain one tree set data structure, and at any moment of time the size of the tree set data structure will be at most k. So if we are processing 1, we need to put the next k elements in our tree set data structure. Then when we are done with 1, we will slide our window by 1. Okay, and we need to put the next k elements from the 7 to our tree set data structures. We can do this by removing 7 from our tree set data structure and adding 10. Okay, insertion and deletion in tree set data structure takes log of k if the size of tree set is k. So similarly, if we slide our window by 1 again, then we need to remove 4 and 7. So at any moment we need to keep the next k elements from the current number in our tree set data structure. Okay, tree set, as I said, will store the numbers in sorted manner and it won't allow any duplicate value. If the first number of our pair is 1, then we know the range of the second number. Okay, in this case it is -1 to 3. Okay, we can find the upper bound of -1 from our tree set data structure, and we can find the lower bound of 3 again from our tree set data structure. Then we can subtract upper bound from our lower bound, and if its value is greater than 0, then it means that there exist numbers in our tree set data structures that lies in this range -1 to 3. So in this case the upper bound of -1 is 4 and lower bound of 3 is null. Okay, so there is no number in this range, in this tree set structure, that lies within this range. We can see that also -1 to 3 there is no number less than -1, or sorry, greater than -1 and less than 3. Okay, so we will move on to the next number 7. We will delete 7 from our tree set and insert 10 in our tree set data structure. So the current state of tree set data structure becomes 4, 10 and 11. Then we will compute the range of the next number of our pair. So 7 minus 2 is 5, 7 plus 2 is 9. This is the range. Okay, we again first find the upper bound of 5. Upper bound of 5 in this tree set data structure is 10, and we find lower bound of 9. Lower bound of 9 is 4. So 4 minus 10 is less than 0. So there is no number in this tree set which lies in the range 5, 9. We can see that also. Okay, there is no number which is greater than 5 and less than 9 in this tree set. Now we will move on to the next number, which is 4. Okay, so the range of 4, next number of a pair which contains 4 is 4 minus 2, 2, and 4 plus 2, 6. 2 to 6. We will first find the upper bound of 2. Upper bound of 2 is 7. Then we will find the lower bound of 6. Lower bound of 6 is null. So there is no number in this tree set data structure that lies in the range 2, 6. We will move on to the next number, which is 11, and we will update our tree set data structure by deleting the 11 and inserting 9. Okay, the range of the other number of our pair is 11 minus 2, 9, and 11 plus 2, 13. We will find the upper bound of 9. Upper bound of 9 is 9, and lower bound of 13 is 10. So lower bound minus upper bound, 10 minus 9, in this case it is greater than 0. So it means there exist number in this tree set data structure that lies within this range 9, 13, and we can see that it is also true. So 9 is number which lies in this range, 10 is also a number which lies within this range 9, 13. So it means that there exists a pair, so we will just return true. Okay, and also please note one thing: what if we have a duplicate in the next k elements? Suppose the next k element is 7, 7, 9. Okay, so we have a duplicate, but since we are using tree set data structure, we cannot store duplicate values. Okay, so to overcome this, we have to maintain another data structure. We can use hash map. Okay, we can use hash map, which is a dictionary. We can maintain the count of each numbers, each next k numbers. Okay, so 7 is 2, 9 is 1. Okay, so whenever we are inserting and deleting our tree set data structure, we will also update our hash map data structure. Okay, so if the value of a key becomes 0, then we will delete that from our hash map and also from our tree set. Okay, otherwise we will not delete from our tree set data structure. Now let me show you this same logic in my code. So I have defined one class contains duplicate 2, and inside this class I have defined one method. I am passing nums integer array and the value of k and t, which is given to us, and I am invoking this method from my main method. Okay, I am invoking on couple of examples. So here I am just instantiating the hash map. I just showed you why we need a hash map: to maintain the count of numbers in the next k numbers from the current position. In the next line, I am maintaining a tree set. I am instantiating a tree set data structure, and first I am initializing the hash map and tree set. I am just inserting the first k elements of my array into my tree set and hash map data structure. I am adding the count in hash map data structure. Then I am iterating over the array from I to num of length -1, and as I showed you, I am first deleting the current element which we are processing from my tree set if the count of hash map is 1. Okay, so if the count is not 1, then we will not delete from my tree set, as I explained here. And if the count is 1, then we can remove the number from our tree set, and we can remove it also from our hash map. Otherwise, I'm just decrementing the count of the number from my hash map. I'm not deleting it from tree set. So over here, I'm just finding the lower bound and upper bound. Okay, using the current number and the value of t provided to us. Then I'm checking if they are null or not. If they are null, if any one of them is null, then it means that the number does not lie in the range. There is no number in our tree set that lies in the range. Okay, so if the lower bound and upper bound value is not null, then I'm checking if the difference lower bound minus upper bound is greater than 0. If it is greater than 0, then I'm just returning true, because there exist numbers in tree set that lies in the range. Okay, so otherwise I'm also checking one more condition here. Okay, lower bound minus upper bound, if the lower bound and upper bound are equal, then I'm just checking using normal method. Like I'm just checking whether this constraint is satisfied or not. So lower bound will be our next number. I'm checking whether the next number of our pair satisfy the condition with the existing number in our pair. Okay, so I'm just taking the absolute value of the difference of num I minus lower bound and checking whether it is less than or equal to t. If it is, then I'm returning true. Okay, over here I am adding the next element. Okay, if the length of our array is greater than I plus 1 plus k, so we need to insert the next number. Next we have to maintain that at any moment of time our tree set structure has k elements. Okay, so I'm just adding that structure, adding that number, next number in my tree set data structure. I am also incrementing the count in my hash map. Okay, this is the algorithm, and let us run the program now. 1 second. Okay, so we can see that it has returned true for the first. Okay, and similarly it has returned the values for all the test cases. So that's all for this video. Thank you guys for watching this video. Bye.